Welcome to Pioneer's Knowledge Hub.
Ever wondered what would happen if you fired a gun in space? It's a question that sounds like it's straight out of a science fiction novel, but it's a thought-provoking scenario that we're going to explore today. Picture it. A lone astronaut, floating in the vast expanse of the cosmos, pulls the trigger of a firearm. What happens next? To unravel this cosmic conundrum, we must consider several factors. The vacuum of space, the absence of gravity, and the immutable laws of physics all play pivotal roles in this interstellar investigation. Unlike on Earth, where air resistance and gravity influence a bullet's trajectory, space presents an entirely different playing field. But it's not all about the bullet. What about the gun, or the shooter? As you're about to see, the consequences of this action are far-reaching, affecting more than just the bullet's path. Intrigued? Good. Let's dive into the science of space and firearms. To understand the effect of firing a gun in space, first grasp the basic physics involved. Let's think about how a gun works here on Earth. When you pull the trigger, the hammer strikes the primer, igniting the gunpowder. The rapid expansion of gases from this combustion propels the bullet out of the barrel. You might ask, how does the gunpowder ignite? Well, combustion requires oxygen, which is abundant in our atmosphere. But when we consider space, a vast vacuum devoid of oxygen, it may seem like this process couldn't happen. Would a gun even fire in the emptiness of space? Here's the twist. Modern ammunition contains its own oxidizer, a component that provides the necessary oxygen for the gunpowder to ignite. This means that a gun wouldn't be reliant on the surrounding environment for oxygen, and indeed a gun could fire in space. Now let's talk about recoil, the backward movement of a gun when it's discharged. On Earth, the force of the bullet leaving the gun pushes back with an equal force as per Newton's third law. However, due to gravity and atmospheric resistance, this recoil doesn't send us flying backwards. In the vacuum of space, things would work a little differently. Without atmospheric resistance or gravity to keep you grounded, the force of the recoil would propel you backwards. It's like being on an ice rink. When you throw a heavy object, you slide in the opposite direction. In space, you'd essentially be floating, and the recoil would push you in the opposite direction of the bullet. So, we've established that a gun can fire in space, and that the shooter would experience a recoil effect, albeit different from what we're used to on Earth. But what happens to the bullet once it's been fired? So, a bullet could indeed be fired in space, but what would happen next? After the bullet leaves the gun, its journey through space would be quite different from what we're used to on Earth. In the vacuum of space, there's no air resistance to slow the bullet down. So, unlike on Earth, where a bullet eventually falls to the ground, in space it would keep moving at a constant speed in the direction it was fired. It's like a cosmic game of billiards, with the bullet as the ball and the universe as the table. And because there's no friction, that bullet could potentially keep going forever or until it hits something. But that's not all. Gravity, the invisible puppeteer, is still at play. If fired at the right angle, the bullet could even be caught in a planet's gravitational pull and start orbiting it like a miniature moon. The infinite journey of a bullet in space, isn't that something? Let's recap what we've learned about firing a gun in space. First off, we've established that a gun can indeed fire in the vacuum of space. This is because the ammunition carries its own oxidizer, a component that allows the gunpowder to ignite and propel the bullet forward. Next, we delved into the physics of the situation, exploring how a bullet would experience recoil differently in space. Absent of air resistance, the recoil in space would be more noticeable, pushing back with equal and opposite force as the bullet is fired. We also discussed the journey of a bullet in space, where it could potentially travel indefinitely. Since space is a vacuum, there's nothing to slow the bullet down or alter its course, allowing it to continue on a potentially endless journey. So, while it's not recommended if you ever find yourself needing to fire a gun in the cosmos, now you know what to expect.
Please do like, share, and subscribe to my channel. Thanks for watching.